All right, so this is Unit 5 we're starting. It is about similarity. You should have already put your name and period on the front cover so we know whose notebook is whose. And again, we will come back to the essential questions in the next lesson. I want to jump right into page 7 to our lesson on ratios and proportions. And we're going to do a little bit of defining what is a ratio, what is a proportion. So a ratio is a comparison of two numbers by division. And there's 3 different ways that a ratio can be written. The most common one and the one you're most familiar with is a fraction. That really is a ratio. A fraction is a comparison of two numbers by division. So having A over B, that is a ratio. We call that a fraction most, but it's also a ratio. You can actually write the letter A and then the word 2 and then B because we're comparing A to B. And then another way to do this is to do A colon B. Those are all 3 saying the same thing, comparing the value of A to the value of B. And because it's a comparison by division, that does mean that we have to make sure and reduce to lowest terms. That is going to be a part of it. So how do we write ratios? Well, the first one says a dwarf lemon tree is 16 inches wide and stands 3 feet tall. What is the ratio of the width of the tree to the height? Now, how do I know how to write a ratio? Is the order the words are given to me. When I look at it, it says, what is the ratio of the width to its height? They list width first. So width becomes my numerator. Height is listed second, so it becomes my denominator. So the order that they ask about things is the order of what goes in the numerator versus what goes in the denominator. Whatever they mention first has to go in that numerator. What is mentioned second goes in that denominator. So if I go back to my problem, they tell me the tree is 16 inches wide and 3 feet tall. So I set up my ratio here, 16 inches over 3 feet. The problem here is I have 2 units of measure. I can't compare things if they're not the same unit of measure. So I'm going to add a little note over here. In order to compare they must be in the same unit of measure. So I can't compare inches and feet. I need to make sure that I'm comparing the same unit of measure. So I should know that 1 foot is equal to 12 inches. So if I take my 3 and multiply that times 12, that gives me 36 inches. So I can rewrite this ratio as 16 inches over 36 inches. Now I'm comparing inches to inches. I'm talking about the same thing. and that I can do, but I also have to make sure I must reduce to simplest terms. So 16 and 36, I know that they are both divisible by 4. So I can simplify them. 16 divided by 4 is 4. 36 divided by 4 is 9. So I can leave it as 4 over 9, or I could write it as 4 colon 9. They are both saying the same thing, that for every 4 inches in the width of the tree, there are 9 inches in the height of the tree. That's the comparison that is happening here. All right, the second one, a rectangle is 12 centimeters wide and 34 centimeters long. What is the ratio of the width to the length? Again, they mentioned width first, so width is going to be my numerator. They mentioned length second, so it's going to be my denominator. I'm going to compare width to length. And in this case, I'm 12 centimeters wide and 34 centimeters long. So 12 centimeters over 34 centimeters. Now, this time, they're both in the same unit of measure. It's centimeters and centimeters. So I don't have to do any conversion on that. I'm already comparing the same unit of measure. So now I just need to look and see, do I need to reduce this at all? 12 and 34 are both divisible by 2. Which gives me 6 over 17, or again, you could write that as 6 colon 17. They both mean the same thing. For every 6 centimeters in the width of the rectangle, there are 17 centimeters in the length of the rectangle. That is the ratio of that rectangle. So we've talked about a ratio, so now let's talk about what is a proportion. A proportion is an equation where two ratios are set equal to each other. So now we're going to be taking ratios, setting them equal to each other, which makes them proportions. So a proportion looks something like A over B equals C over D. So you have your two ratios that have been set equal to each other. Now the question comes, well, how do I solve a proportion? And we're going to use cross multiplication. So we're going to cross multiply. So if I take that same proportion from above, A over B equals C over D, cross multiply means I'm going to look at my diagonals. So A and D are in the same diagonal. So I'm going to take A times D, and that's going to be equal to the other diagonal, which is B times C. So again, I'm going to be looking diagonally and multiplying those together, whether they're numbers you're multiplying together, a number and a variable, or expressions. We're going to see a little bit of everything here in the examples. So number 3 here, I have x over 2 equals 6 over 7, so I'm going to look at one diagonal. And it doesn't matter which diagonal you do first. So I have 7 times x equals, look at the other diagonal, 2 times 6. Then I need to simplify that, so 7x equals 12. And then I need to divide both sides by 7. So we'll get x equals 12 sevenths. 7 is a prime number. It doesn't go into 12. So we would just leave our answer as 12 sevenths. It is okay. It doesn't always have to be a nice, pretty whole number. But we do need to make sure that we are reducing whenever possible. Number 4, 2 over 4 equals 4 over the quantity a plus 4. So again, when I go to do my cross multiplication, I have 2 times the quantity a plus 4 equals the other diagonal of 4 times 4. Now, when you get into the expressions, you do have to distribute. So that 2 on the outside has to be multiplied times both terms inside. So we're going to distribute that 2. So I have 2a plus 8 equals 16. Subtract 8 from both sides. So I get 2a equals 8. Divide both sides by 2. And a equals 4. All right, on to the next page with more examples. Now we're seeing an example of a combination of an expression and just a single variable. So again, looking at my first diagonal, I'm going to have 5 times y equals 8 times the quantity y minus 10. And again, anytime I have an expression, I have to distribute through to that. So I get 5y equals 8y minus 80. Subtract the 8y from both sides. Negative 3y equals negative 80. Divide both sides by negative 3. And we get y equals 80 thirds. 3 does not divide into 80 evenly. So that would be our answer. Again, if we can simplify, we do, but in this case, there's nothing that goes into both 3 and 80 evenly. Number 6, 5 over the quantity 5x plus 3 equals 8 over x. So one of my diagonals is going to be 5 times x, and that's going to equal my other diagonal of 8 times 5x plus 3. Again, we're going to distribute. So I have 5x equals 40x plus 24. Subtract 40x from both sides. Negative 35x equals 24. Divide both sides by negative 35. And we get x equals negative 24 over 35. If we're looking to reduce, the only numbers that go into 35 are 5 and 7. Neither of those goes into 24. So this would be our answer, negative 24 35ths. Number 7, 5 over r plus 4 equals 7 over r. Again, cross multiply. So I have 5 times r equals, my other diagonal is 7 times r plus 4. And again, I have to distribute on that right-hand side. So I have 5r equals 7r plus 28. I'm going to subtract that 7r from both sides. So negative 2r equals 28. Divide both sides by negative 2. And we get r equals negative 14. So it's possible you could get a whole number. It's possible you could end up with a ratio. Just depends on the numbers that you are given. Number 8, 8 over the quantity 3x plus 3 equals 10 over the quantity 7x minus 7. So now in number 8, we're going to end up with two quantities. So we're stepping it up another level, but still the same way to solve. We look at one diagonal here. So on one side, I'm going to have 8 times the quantity 7x minus 7. And that's going to be equal to the other diagonal of 10 times the quantity 3x plus 3. Since there's quantities on both sides, that means I have to distribute on both sides. So on the left, I'm going to distribute the 8, and on the right, I'm going to distribute the 10. Again, anytime I have quantities, I'm going to have to distribute. So I have 56x minus 56 equals 30x plus 30. add 56 to both sides. 56x equals 30x plus 86. Subtract 30x from both sides. 26x equals 86. Divide both sides by 26. So x equals 86 over 26. But I know this can be reduced because they are both even, so I can reduce them both by 2 to get x equals 43 over 13. Number 9, 6 over 3 equals the quantity x plus 7 over the quantity 7x minus 5. Again, I'm going to go for my diagonal. So on one side I have 6 times the quantity 7x minus 5 equals my other diagonal 3 times the quantity x plus 7. Again, I end up with quantities on both sides, so I'm going to have to distribute on both sides. On the left, I'm going to distribute the 6. On the right, I'm going to distribute the 3. So we get 42x minus 30 equals 3x plus 21. I'm going to add 30 to both sides. So 42x equals 3x plus 51. Subtract 3x from both sides. 39x equals 51. Divide both sides by 39. And we have x equals 51 over 39. These are both divisible by 3. So we have x equals 17 over 13. Number 10, 2 over 10 equals 5n plus 4 over 2n plus 9. My first diagonal, 2 times the quantity 2n plus 9 equals my second diagonal, which is 10 times the quantity 5n plus 4. Again, quantities on both sides, so I need to distribute on both sides. So I have 4n plus 18 on the left, 50n plus 40 on the right. Subtract 18 from both sides. And we have 4n equals 50n plus 22. Subtract 50n from both sides. So negative 46n equals 22. We're going to divide by that negative 46. So n equals negative 22 over 46. And again, these are both even, which means I can reduce them by 2. So n equals negative 11 over 23.